Hello everyone. Today we are going to solve this problem. In this figure below, we have the inner system of cathode-ray oscilloscope. In the system of cathode-ray oscilloscope, the electrons are emitted from positively charged anode to the cathode. Then the electrons will start to move from the cathode with initial constant velocity towards z direction, and this is the equation of the initial velocity. Then at z equals 0 in this region, at z equals 0, the electrons will enter the area of deflection plates. Between these plates we have an electrical field which is downward, and this is the equation of the electrical field between. It's toward negative y direction. And as the electrons are negatively charged electrons, and these plates, and between these plates we have an electrical field. As the electrical field is downward, then this plate is positively charged and this is negatively charged. The electrons will start to travel with some deviated path, and at the end it will fall on some fluorescent screen. In this problem, we want to find the vertical deviation or the vertical deflection of electrons during this path, or how much this electrons deviates. Before start solving, we have two parameters that we can take the advantage of, which is W, which is representing the length of the deflection plates, and L, which is representing the distance between 0 and the fluorescent screen. And now, as we see, when electrons are moving between the deflection plates, is going to be affected by the electrical force. So the electrical force that the electrons experience is equal to the charges of the electrons times the electrical field. And as these electrons are negatively charged, so I will add the minus, the negative sign. Okay, as this electrical field, we said it's E sub d, and the force is vector as well. Okay, now I will substitute the equation, the formula of the electrical field into this and I will retrieve A sub y. Okay, now as we see, according to this sentence, ignoring gravitational effect, so the only force that the electrons are experiencing between deflection plates are the electrical force. So this force is equal to the net force that the electrons are experiencing. And according to Newton's law, this net force, the net force that some particle experiencing, is equal to the mass of this particle times the acceleration that this body is moving with. And as we know, the acceleration is the first time derivative for the velocity, so I will put du over d sub t. Okay, and as electrons, due to the electrical field, these electrons are going to deviate upward. It's going to deviate vertically toward y direction, so I will add this y subscript in order to distinguish it from the initial velocity, which is toward z direction. Anyways, now we can divide, and of course this is vector also, and it's toward y direction. We can eliminate the unit vectors, and we can write this equation in this way. Now take the time integration for both sides. Now take the integration for both sides. We will end up with this is constant, so we make no change upon it. Now the integration of d of t is equal to t plus C. Okay, and in order to find the value of C, we want to substitute 0 for the time y sub y when t is equal to 0 is equal to S. Okay, and now look at the problem. When electrons, before the entrance of electrons to the deflection plates, it was not moving toward y direction. It was not moving vertically, so there is no vertical force. So there is no vertical velocity before entering the deflection plates. So the vertical velocity at time equals 0 is equal to 0. Then u sub y is equal to E over m E of d t. And as we know, this velocity is also it's the first order differentiation of the position equation. Now take the integration again for both sides of this equation, and we will end up with u is equal to E over 2m E d times t squared and plus C. And look at the problem. Before entering deflection plates, the position with respect to y was 0, so C is equal to 0 as well in this case. So y is equal to, as we see, this equation is the vertical position of electrons when it's moving between these deflection plates. So if we wanted to find the deflection or the deviation that electrons experienced when it was between the deflection plates at, for example, at this point, okay, we want to substitute t for the time elapsed when electrons are moving in this inside this area, and this time is equal to the distance that the electrons passed, which is w in this case, okay, divided by the velocity. The velocity that was electrons are moving in this towards the z direction, it's constant velocity, and it's u sub 0, so divided by u sub 0. Now substitute this into this equation, and we will reach to the deviation, to the initial deviation when electrons was moving between these deflection plates, and it's equal to but this is not the end of the problem. This is firstly the initial deflection due to the deflection plates. Now electrons, when electrons reach to this region, it's going to continue its path with constant velocity, because at this region the electron is not affected by any another source of force, so it's going to move with constant velocity with respect to z and with respect to y as well. So as we calculated before, the velocity when electrons was moving between the deflection plates was equal to this, okay, y with respect to y is equal to OE over m times ED times t. And when electrons reach to this region, it will start to move with constant velocity with respect to the vertical axis. So substitute t with w over u Now we want to find the vertical deflection that will electrons experience. We want to find, this is the vertical deflection, this is d sub 0. We want to find d sub 1, the vertical deflection between the deflection plates and the screen. And this d1 is equal to the distance is equal to the distance that electrons passed with respect to the vertical axis, and it's equal. And this distance is equal to the time elapsed. The time elapsed between these two regions, between W and L, is equal to the distance between W and L, which is L minus W. D1 is equal to L minus W divided by the velocity needed to pass this region. And as we said, the velocity with respect the velocity towards z direction is constant, and it's equal to u sub 0. This is the time, and now we want the velocity, and we said this velocity is constant with respect to y, and this is u sub y. Now substitute this for u sub y in this equation, and we will end up with sorry, I just forgot either. Anyways, in order to find the total deflection that electrons experienced, we want to add these two deflections, d sub 0 and d sub 1, and we will reach 2d is equal to d sub 0 plus d sub 1. Just add both of them and we will reach 2. And this is the total deflections that electrons experienced. Thanks for watching. See you in another video.